Hello and Merry Christmas, and welcome to this video tutorial, which is going to be the second in a three-part series on IPv6 over MPLS L3 VPN. So in the first video, we took a look at leveraging the existing and kind of ubiquitous MPLS L3 VPN from an IPv4 perspective. There's a massive footprint of deployed IPv4 MPLS L3 VPN networks out there, and how we would be able to go ahead and get IPv6 over that IPv4 transport by simply creating a tunnel between the customer A router here, and we'll say we're going to change it up now, we're in San Francisco, and then this one here in New York City. And simply we just built an IPv6 tunnel between these two routers, leveraging the existing IPv4 connectivity to the loopback addresses. And we had two LAN segments where we wanted to do IPv6 with these LAN segments. And that is one way to get things done. Now, remember, we talked about some of the drawbacks. The first is that your routing information for these IPv6 networks, it's all hidden from the provider. So really, the provider is not going to see anything because the provider routers are not running dual stack, so there's no IPv6 at all in the first scenario that we looked at. So now what we're going to do is we're going to sort of look at the maturation process of how to run IPv6 over an MPLS cloud. And so if we look at what we have here, this is what we call the IPv6 provider edge, or as Cisco calls it, 6PE. Now, for 6PE, we're going to have the provider edge routers, provider edge routers are going to be dual stack. So everything running in the core of this MPLS network is IPv4. So we still have an IPv6 unaware MPLS core. However, at the edge is where we have our IPv6 connectivity. Right? So the provider edge routers are going to be dual stack. Now, you certainly could be dual stacked out here with the customer side, but you don't have to be dual stacked. Again, when we're talking about 6PE, one of the major differences is there is no VRF interface here. So our peering, right, this IPv6 peering that we're going to have between the customer edge router and the provider edge router is going to take place in the global routing table. So that's the first significant difference. The next difference is like I said, we have no VRFs. If we had VRFs for these peerings, what this would be called, and is going to be our third and final video, is we would call this 6VPE. And that V obviously referring to the VRFs that we would have on the provider edge routers. But here we don't, right? So we first looked at what happened with no IPv6, and we just went ahead and said, okay, not a problem. We're going to do IPv6 tunnel over IPv4. So IPv4 was my transport protocol, and it was transporting my IPv6 passenger protocol. Now we're saying that the providers have upgraded here. The provider has said, yeah, you know what? Hey, we're now doing dual stack. So our provider edge routers are IPv4 and IPv6 capable. And the customer says, hey, that's great. We want to participate in the global IPv6 network. So make sure that what we're doing here, we're going to be doing everything in the global routing table. So it's not a point-to-point type relationship or point-to-multipoint with these VRFs. So we will have no VRF interfaces on the provider edge router. That, again, is going to be our third and final video where we take a look at 6VPE, or 6 VPN provider edge. Okay, so let's dive in here. Let's jump on the command line. And I've cleaned up the configs that we had previously from our IPv6 over IPv4 tunnel. So let's go ahead and let's set these peerings up between the customer and provider edge routers. Now, for my route students, if you remember, we actually did a lab where we ran IPv6 over IPv4 with BGP. And literally, that is how straightforward this scenario is. We're doing the exact same thing where we're going to go under the address family for IPv6 and actually put the IPv4 addresses in there for our provider edge router. So let's go ahead and dive in here. Let's go from user exec to privilege exec into global config, and let's say do show run section BGP. Let's make sure we have no BGP sections, so it's been totally wiped out. Do show run interface serial 010. All right, so you can see we have an IPv4 address in there. Let's clean this up. So let's go ahead. We're going to say that, again, we're a customer, total greenfield environment here, and we want to go pure IPv6. Again, remember, the customer side of this equation does not need to be dual stacked. In fact, a use case for this, again, is a greenfield IPv6 deployment with the customer, and they're not going to be doing any IPv4. All right. So we've removed that address, do show run interface serial 010. So that's all we have on the interface is that IPv6 link local address and the IPv6 global unicast address. So now let's say router BGP 65431. Whoops, let's make sure we get that BGP in there. 65431. And we're going to go ahead and say no BGP default IPv4 unicast. And let's put our neighbor statement in here. So the neighbor is going to be 2001:DB8:1212:2. And the remote autonomous system is 1. Then let's move down to address family IPv6 unicast. Again, remember, we're on the customer router here. So the customer is treating this as if this was just a normal IPv6 pairing. So we say address family IPv6 unicast, and we're going to pull that neighbor statement back. And we're going to say activate. And in fact, let's go ahead and say do show IPv6 interface brief. And we should have a loopback address. And so we're going to use, again, sort of to simulate, hey, that we're going to advertise this IPv6 segment, which, again, it's the loopback address is just simulating an IPv6 network that we've got maybe off an interface on the router here. So let's go ahead and add a network statement in here for 2001:DB8:, and what are we using here? 1111::/64. And so we're going to be advertising that network. So what do we have here? And actually, let me add in here, whoops, let's exit out. Say BGP log neighbor changes. There we go. All right, so do show run section BGP. And again, this is the customer edge router. And so from the customer perspective, everything we're doing is IPv6. So we just simply use the address family for IPv6. And we have our neighbor statement. So we're ready to go from this perspective. So now we need to get on to the provider edge router. And let me save the config here just in case. So let's go to router 2, with whom router 1 is going to be establishing this pairing. User exec to privilege exec into global config. Do show run section BGP. So here you see we have an IBGP relationship set up here between the two provider edge routers. Again, we're going to be following a pure label switch path through this environment. And that's really what allows us, when we put the BGP label on, and we'll talk about the labeling. So we're going to see a label, but it's not going to be an LDP generated label, right? It's going to be, and it's not going to be a VPN label. Remember, we're not talking about VRFs here. It's simply going to be a BGP generated label for the prefix in question that is going to allow us to be switched through the environment. All right, so we're in the provider edge router here. Let me take a look here. So we got the neighbor statement. So we're going to, let's complete the configuration with router 1. So router BGP 1. Now, remember, this is an IPv6 peering that we're setting up. So let's go ahead and say neighbor 2001, and there are no VRFs here, so it's not going to be address family IPv6 VRF. It's not going to be address family IPv4 VRF, right? It's in the global space, so it's in our global BGP config section, neighbor 2001 DB8 colon, and we were 1212. Is that right? Let me double check here. I'm sorry. I got to back up here. And where is that interface? Yeah. Oops, sorry. Yeah, DB8 1212 colon colon 1. All right, so there we go. 1212 colon colon 1, and the remote autonomous system is 65431. And now we're going to go into the address family for IPv6 Unicast, and we're going to say, pull that neighbor statement back up and activate. And so what should happen here is we should see this BGP peering come up. Let me make sure we have connectivity here, 2001 colon, and there we go. Okay, good. So just wanted to make sure we were good to go. So again, it's all in the global space. So when I say do show BGP IPv6 Unicast, what should we see in here? You've got it. So we're picking the prefix up from router 1, right? The customer edge router that's located in San Francisco. And so we're picking up that prefix. So let's come all the way over here to router 3 and see, are we seeing that prefix over here on the other provider edge? And they'll say this router's out in New York. So show BGP IPv6 Unicast. We don't, right? We're not seeing anything. Because remember, there is no IPv6 peering between these routers. Let's get back to the drawing here. So between the provider edge routers, so we're good, right? The loopback 0 IPv6 prefix, and we'll say there's our 0, gets advertised in here, but again, it's IPv6. Everything going this way and everything coming this way, it's all IPv4. So we don't see the prefix over here. And in fact, the iBGP peering that we have between these two routers is IPv4. Now, remember, if you remember back to the scenario, and it was in one of the Cisco Learning Labs exercises, where we said, okay, well, I want to do IPv6 as the passenger and IPv4 as the transport. So here's the IPv4 transport. It's already in place. Now the question is, how do I get the IPv6 passenger? And we're also going to have an advertisement here that's going to come in as IPv6. How do we send that across this iBGP peering so that it's label switched along the path? Well, we do the same thing that we did in the lab. And again, it's very, very straightforward. So on the provider edge router, and actually let's do this first. Let's come over to router 7 and let's stand up the customer edge on this side. So let's say show run section BGP. And there should be no BGP section. How about show interface serial 010, which I believe, oops, how about show run? Show run interface serial 010. And show run int serial 000. Yeah, so there's our interface. Let's get into global config. Let's jump into serial 000, and we're going to pull the IPv4 address off. Again, remember, we're kind of pretending here that we are a greenfield IPv6 environment. So now we only have, do show run int serial 000 IPv6 addresses, because again, remember, the provider edge routers are dual stack because they're doing IPv4 MPLS L3 VPN, right, or MPLS, MPLS, and the customer edge routers are pure IPv6. Now, they could be dual stack too, nothing wrong with that, but we're saying in our scenario here, in this use case that we're looking at, that it is going to be simply IPv6 only on the customer side, dual stack v4 and v6 on the provider edge side, but in the core, it's nothing but IPv4 in that MPLS core. So let's go ahead and say router BGP 65432, BGP log neighbor changes. How about a no BGP default IPv4 Unicast? And let's put our neighbor statement in here, and it's going to be 2001 colon DB8 colon 3737 colon 3. remote AS1, and then let's get into address family for IPv6 unicast. Pull that statement back and activate. And we're going to activate it there. All right, so let's also add in do show IPv6 interface brief, a loopback address. That way we can share some information. So we're going to say network 2001 colon db8 colon 7777 colon slash 64. All right, so what do we have here? So do show run section BGP. So again, this is the other customer router, right? All IPv6, pure IPv6. So now let's jump onto router 3, the provider edge router, where we're going to do much of the same thing that we did with the provider edge router, router 2. Do show run section BGP. And that's all we have right now, right? We've got that IPv4 peering between router 2 and router 3. So let's jump into router BGP1. And again, no VRFs here. So this is in the global BGP config section. So neighbor 2001 db8 colon 3737 colon 7. If I remember that correctly, remote AS 65432. And then address family IPv6 unicast. And we're going to bring that neighbor up. And we're going to say activate, and we should see that neighbor pop up here. And let's get prepared for a do show BGP IPv6 unicast. All right, great. The neighbor comes up, and we should be picking up that IPv6 advertisement, and we are. So, but I'm not getting the advertisement from the other side. So right now, we have both PE routers, both provider edge routers have an IPv6 peering, and both provider edge routers are picking up that v6 prefix that's being advertised from the customer edge. But ultimately, the customer in San Francisco wants reachability to the IPv6 segment that it's being advertised here to this provider edge router, and vice versa, right? And those loopback 0 interfaces. So now the question becomes, okay, well, you're running MPLS with IPv4 in the core, because again, the core, there is no IPv6 in here. None. It is all IPv4. And this is one of the benefits of 6PE, is that you can leverage your existing MPLS core as a provider, dual stack on the edge, and you can offer v4 and v6 services to your end customers. So, but now here's the question. How do we bridge this gap, right? And this is the gap I'm talking about right in here, right? How do we bridge that gap with the v6 information that both these provider edge routers have, but are unable to communicate to each other? And so this kind of goes back to the lab that we had when we wanted to do v6 over v4. Okay, so excuse me, we've already in the global section configured the IPv4 peering statements. So now we just go under the address family for IPv6, right? So we're basically going to have an IPv6 control plane running over the IPv4 transport. So from here, we simply say neighbor 2.2.2.2 activate. And what do we have now? Do show run section BGP. And so here's the BGP section on router 3, which is PE2. And we've basically just activated under the IPv6 address family the IPv4 neighborship. And now let's go over to router 2 and do the reciprocal work for router BGP. Whoops, sorry. Router BGP1. And do show run section BGP. And so this is what we have. So we'll go into address family IPv6 unicast and simply say neighbor 3.3.3.3 activate, right? And so now we've basically set it up so that we have an IPv6 control plane running over the IPv4. But let's take a look. And there you go. You can see the BGP adjacency has said that it is up. So if I say do show BGP IPv6, IPv6 unicast, what would we expect to see? All right, so now we actually are receiving the 2001 DB837, I'm sorry, the 2001 DB87777, right? However, you'll notice we don't have the greater than sign yet for the valid, or I'm sorry, for the best. It shows as valid but not best, and why do you think that may be? Well, we take a look here, and you can see we've got this IPv6 next hop address that we do not have a route for. We don't have a route over to 3737, so that's why it's going to show as not valid. But again, we want it to take the label switched path. So there's one more command that we need to run underneath the IPv6 configuration section where we put the neighbor statement in here, and that is send label. Because again, we're basically going to be labeling the prefixes. And there you go. You can see the adjacency came back. And let me come over here to router 3. And let's rerun that command over here with send label. So we're sending, or we're basically having BGP attach a label, right, so that it can be MPLS switched. So now when I say do show BGP IPv6 unicast, what do we see? Yeah, interesting. What do we see here? And you probably remember this from the lab that we did on the Cisco Learning Lab site when we came up with this IPv4 embedded address inside of an IPv6 address, right? So here's the IPv4 portion, and this is how BGP knows what the next hop is going to be. Remember, we established that IBGP peering in the address family for IPv6. So this didn't work when we did the lab. We had to do a route map in order to make the change so that you would be able to actually route traffic through the IPv6 traffic would be routable through your IPv4 infrastructure. However, here, right, we don't need a route map to solve anything because we added in the label capability. So BGP is actually communicating this prefix, right? So we're on router 3 here, and you can see that this is coming from, we know that's coming from the customer edge router, router 1, with a next hop saying, hey, come to 2.2.2.2. Well, BGP is going to know how to handle this because it's affixing a label. So let's take a look at that. In fact, you can see that this capability changed, right? So we had to renegotiate the capabilities. In fact, if I were to say, do show BGP IPv6 neighbor, we should see, and there it is, IPv6 MPLS label capability between the two IBGP provider edge routers. And so what we have right now, and let's get to the drawing here, what we have right now is this IPv6 control plane running between the two provider edge routers, but the transport is IPv4. Again, it is all IPv6 unaware in here. The provider core, MPLS core, has no clue that there's IPv6 traffic flowing across the core, right? Because it's leveraging this IPv4 transport. And it's all taking place because we're affixing that label. So let's check something out here. Let's see from the customer edge routers, do we have reachability? And so let me get back on our command line here, and let's push all the way over to router 1 out here in San Francisco. So if I'm all the way out here, if I were to say show BGP IPv6 unicast, take a look at that. I have a best and valid prefix for the 1212, so that's my to get to that prefix, that's my next hop. But again, take a look at that. I know exactly how to get there. So, right, so now that we see that we're learning the 7777 IPv6 prefix, and again, this is being originated over from Autonomous System 65432, which again is router 7. It's the customer edge router in New York City, and we've got a legitimate next hop value. Now let's go ahead and validate, do we actually have full reachability? So can people in the San Francisco office, leveraging the MPLS cloud, which is IPv6 unaware in the core, outside of the provider edge routers that have an IPv6 pairing with the San Francisco and New York City offices, do we have full reachability? So let's check it out. 2001 DB8 colon 1234. Oops, sorry. Let's get a colon in there. Colon 7. Can I ping? Actually, I apologize. Let me source that. Control 6. Come on now. Control Shift 6. There we go. So I source it from my loopback 0 address, which is that IPv6 address, which is also being learned over on the other side, and we see that we've got full reachability. So what about the labels, right? How are the labels working? Well, let's check and see if I'm following that label switch path. Let me kick this off again here, and we're going to say repeat, and we'll put a pretty large number there. So we'll get some pings going. Let's pull up Wireshark, and let's say start the capture, which we're going to be able to end rather quickly, just like that. And so you can see we've got a lot of pings. So let's take a look at an echo request, right? It's from 1 to 7. Let's see what we've got inside here. And if we collapse this down, kind of give us an idea, we can absolutely see we've got an MPLS label switch packet. Again, in hexadecimal, it's 8847. You can see that right there. So here's my layer 1, the bits on the wire, or the bytes on the wire. I've got my layer 2 Ethernet header. Again, the ether type telling me that this is going to be an MPLS label switched packet. Then we come into the first, or the top, MPLS header, and again, this is between router 2 and router 11, 11 being that center router. And so router 2 knows, hey, I'm going to put label 1100 on there, because to get to the 3.3.3, which is that next hop, that would be the label that we put on there. If I come down a little further here to the bottom label, right, and this is that BGP label that we're using, and the bottom of stack label, you can see that it's label number 306. When we come into the IPv6 packet, right, this is the layer 3 information. You can see the source and the destination, and again, this is all being hidden from that IPv4 core because we have these MPLS headers, right? These MPLS labels are basically making sure that those core MPLS routers simply ignore that IPv6 source and destination information, until which time, and again, when we get to that penultimate hop pop, or I should say the provider edge router, is going to remove that label, and then here is our ping request again. If I were to go over to PE3, right, which is the, or I'm sorry, PE2, router 3, and if we were to say show BGP IPv6 unicast for the 2001 DB8 7777 7/64, you can see right here that the label is actually listed. This is where we're getting that 306 from, and it says MPLS labels in would be 306, and so it knows that if I receive a packet that has the MPLS label, this is the provider edge router, router 3, PE2, if it sees a packet show up with an MPLS label of 306, it says, okay, no worries, that is my next hop address. And that just happens to be the next hop address of router 7, who is the originator of that IPv6 prefix. And so you can clearly see end to end how we have the MPLS label switch path working for us, and basically hiding that IPv6 information, right? These prefixes and the prefix links and the next hops, all of that is hidden from that MPLS IPv4 core network on the provider side. So let me go ahead and clear this here. Whoops, let's clear that out. All right, so let's take one last look here. If I say show run section BGP, that's the provider edge router. Again, we have to send that BGP label. If we come over here to the PE1 router, router 2, show run section BGP, that's the configuration there. And on the customer side, very simple, right? Very straightforward. It's just an IPv6 peering. And that's it on both routers 1 and 7. And so there you go. And this is the 6 provider edge solution. But again, remember, all of that will be in the PE router. If I were to say, show IPv6 route, right? Take a look. All of those routes are going to be in the global table. So if you're trying to peer with a provider and you want to play in the global space, this is how you're going to do it, right? You would want to do 6PE. 6PE would be the solution for the use case where you want to peer with the provider, but you want to participate in the global IPv6 address space that provider, or I should say the global IPv6 routing table that provider is going to have. Now, if you don't want to be in the global routing table and you don't want this information to be seen and you want it to be sort of a point-to-point virtual private network, that's where we're going to get to 6VPE, and that is going to be the final of the 3 videos in this series on how to get IPv6 or communicate with IPv6 over an MPLS L3 VPN environment, whether it's IPv4 in the core or if we were doing tunnels. So we'll take a look here. So again, remember, this is IPv6 unaware in the MPLS core, and this is the 6 provider edge solution. All right, the final video is going to be the 6 VPE, where we're now going to have VRF interfaces on the provider edge routers to deal with these IPv6 peerings, and it's still going to be label switched over the core, but it will not show up in the provider's global routing table. All right, thanks so much for watching. Have a Merry Christmas and a Happy Holidays.